Welcome to this presentation on green speed. The most intensively managed part of the golf course is the putting green. It is the place where all golfers end up, and the only place where you intentionally roll the ball along the ground to get it into the hole or cup. Thus, there are certain characteristics that are associated with a good putting surface. I will focus on uniformity. Uniformity implies that there is a consistency from green to green and within the putting green. That the greens are smooth so that the putt follows a true line and does not bounce offline, and the greens have the same relative firmness that speaks to the ability of the putting surface to hold a well-struck shot. How we measure uniformity is to a large extent by the green speed, or how far a ball will roll out when placed on an incline. Now let's look at how measuring green speed evolved. I have always liked this picture, not only for how well dressed the caddies are, but also as a perspective on the condition of putting greens in the middle of the 19th century. These three golfers are putting on a green by today's standards would be considered a heavy rough. As golf progressed and arrived in the United States, an accomplished amateur golfer by the name of Edward Stimpson was curious about how to quantify a good putting surface. He asked the question, how could we measure putting green speed? He developed a wooden instrument that was V-shaped, and you could roll a golf ball down the stick and measure the distance from the end of the stick to where the ball stopped. This distance was known as the green speed. The Stimpmeter he created is shown in this 1937 publication, where he describes what he had invented. How popular did the concept of green speed become? We kind of get an idea how golfers were interested in this picture as they watched Edward Stimpson demonstrate his instrument. In this slide, you can see the original wooden instrument of Edward Stimpson. Subsequent Stimpmeters, the green and the blue ones, were developed by the United States Golf Association based on the original. The first USGA Stimpmeter would not become available until 1976. In this table are some measurements that Edward Stimpson made in 1937 at a few golf courses in the Massachusetts area. His Stimpmeter is not the same as the USGA ones, so the actual numbers can't be reliably related to current Stimpmeter readings, but the values give you an idea of what he was measuring. Note that in all but one situation, the green speed was less than 3 feet, extremely slow and unacceptable by today's standards. Edward Stimpson would continue to measure green speed through the years, but the general use of his device was greatly limited and for the most part had little effect on golf course management. That would all change in the mid-1970s. The United States Golf Association in the mid-1970s developed the Stimpmeter, naming it in honor of Edward Stimpson. The Stimpmeter itself is 36 inches long with a V-shaped groove extending its length. 30 inches from the base is a notch where a golf ball is placed. The Stimpmeter is laid flat on the green and is then slowly raised until it reaches a critical angle, which is approximately 20 degrees. The ball rolls down the Stimpmeter. When determining green speed, the Stimpmeter measurement should be made on a flat portion of the green, as shown here. The average of 3 ball rolls is taken, and the distance traveled from the base of the Stimpmeter to the average end point of the 3 balls is measured. Measurements are made in feet and inches. The process is repeated in the opposite direction and the average distance taken of those 3 balls. The average of the 2 measurements gives the Stimpmeter reading. The USGA tested the Stimpmeter on 1,500 greens in 36 different states and found that the average green speed was 6 feet 6 inches. In 1978, the Stimpmeter was made available to golf course officials and golf course superintendents. How has the Stimpmeter impacted golf? For one, green speeds have greatly increased. In this survey of putting green speeds for daily play on golf courses in the west and northwestern United States, we can see that in 1977 the average green speeds were in the 6 to 7 foot range. On those same courses 27 years later, the green speeds are in the 10.5 foot range, an increase of 3 to 4 feet over that period of time. That same data previously presented is shown here in graph form. As a reference point, Dr. Nikolai at Michigan State University found that a ball roll or green speed of a pool table is 15 to 16 feet. The downside to green speed is that you can lose your turf if not closely monitored. One of the major management practices to increase green speed is to reduce the height of cut. The less plant tissue available, the less resistance to ball roll. Lower heights of cut add to the stress of the plant that can make it susceptible to injury from various environmental, biological, and management stresses. Here are some photos from a study done by Dr. Nikolai at Michigan State University, where he looked at the impact of height of cut on turf health and green speed, but the focus here is on turf's health. The height of cut is 0.063 inches, which is extremely short height of cut, probably the lowest you can currently go. Notice the plots that are highlighted. They are dead. In this picture, the treatment is the same height of cut, but double cut was done with the same results. In this photograph, the treatment is a higher height of cut, 0.094 of an inch, but is still extremely low, but in this case only single cut. Now in this picture, it's the same height of cut as previously shown, but in this case it's double cut daily. So you can see the impact of height of cut and frequency on turfgrass health through this series of these 4 pictures. I did an informal survey of golf courses in 2012 in the Cincinnati, Ohio area, and basically asked the question, at what Stimpmeter reading do you see turf injury? I did not define injury, but basically, as you can see, as the putting green speeds increase, the possibility of turf injury also increases. So what is a good putting green speed? It depends. Biology, or these small plants growing on these greens, is a complex system, so the speed can depend on environmental conditions present, the quality of equipment, and the expertise of the ground staff. If you are looking for a general number, and I have to be careful what I say, but at high-end course, the Stimpmeter readings are probably in the 10 to 10.5 foot range. But again, Stimpmeter readings are based on a flat surface, and putting greens are not necessarily flat. Similar to racing, speeds can increase along a straight or flat path, but need to slow as you enter a turn or curve. Greens act the same way, except for curves on greens we call them contours, or humps that can cause a putt to curve or break, and depending if you are going up a hill or down, increase or decrease speed. You can see the contours on this green and on this green. Accounting for contours is an important aspect of uniformity. As a general rule, a golfer should be able to stop the ball within 2 feet of the cup. To demonstrate this point, these gentlemen are PGA Tour officials trying to determine if this green is too fast on downhill putts for the proposed hole location, which is designated by the black radial. If the ball can't stop within a reasonable distance of the cup, then the hole location is lost because it is ruled unfair by the officials. In this specific example, the hole location was acceptable. This graph shows the impact of green speed on hole or pin location. Notice that in 1925 it was acceptable to have pin locations on a 6 to 7% slope, which for the most part remained that way through the 1960s and mid-1970s. But with the release of the Stimpmeter, note now that an appropriate hole location is less than 2% for most PGA Tour events. This is a reflection of increased green speeds. As speeds have increased, greens have become flatter and for the most part larger. Like racing, much has changed in how we achieve a desired green speed and still maintain a healthy turf. This photograph was taken at the Grand Prix of Monaco Race Museum. Notice the sophistication of the recent race car pictured, but also note the pictures in the background of racing cars of the past. The cars and how we gain speed is much more sophisticated and in many ways safer. I like to use this photograph of two Shelby Ford Mustang Cobras as an analogy to show you how we achieve green speed. Both cars generate over 500 horsepower, but the car on the right is from the late 1960s, while the car on the left is a model between 2007 and 2009. I ask you the question, which car would you rather be driving at a high rate of speed? The car on the right obviously can go fast, but looks like a big engine with some metal strapped on. The likelihood of injury would be greater with this older car. Regarding green speed, the same thing can be said. Due to technology improvements in equipment, improvement in turfgrass species, and the expertise of golf course superintendents to manage greens, we can achieve greater green speeds with less risk of injury. In addition, like the previous slide, achieving green speed now is much more complex, or I would say balanced too. Instead of just dropping the height of cut, we can implement management practices including rolling, brushing, top dressing, proper watering, precision fertilization, and using compounds like plant growth regulators, to name a few, to give us a desired green speed and a relatively healthy putting surface. If we set unachievable putting green speed expectations, we can quickly end up in a situation like this, or this. Green speed is a good thing if we use it properly, for example, to determine the uniformity of our putting greens on our golf course.